This is an example of dimensional analysis to show if an equation might be correct. The entire idea of dimensional analysis is the dimensions on the left side of an equation must be equal to the dimensions on the right side of an equation. So let's pick an equation that should be correct already, since it is a verified physics equation, and prove that it might be correct dimensionally. Let's use this equation. Delta x equals v0 times t plus 1/2 a t squared. To do this, you have to know the dimensions of each of those quantities. Since this is early in the course, they'll be provided for you. Delta x is called displacement, and it has dimensions of length, or L. V0 is a velocity, and it has dimensions of length divided by time. A is acceleration. It has dimensions of length over time squared. T is time, so it has the dimensions of time. Now, to work with dimensional analysis, you always leave one side of an equation alone and work with the other. So here's what we want to do. Let's put in dimensions for each of the quantities. So delta x, L. And we will use this little symbol that says, is it equal to v0 velocity, L over t times t plus 1/2 a L over t squared times t squared. So the goal is to see if the right side shrinks down to L. If it does, they're equal and it is dimensionally consistent. So L, is it equal to? Well, L over t times t, the t's will cancel, L plus 1/2 L over t squared times t squared. The t squareds cancel. We also have L. So when we add a dimension of length to a dimension of length, we still get a dimension of length. The 1/2 is a scalar, which doesn't mean anything. It has no dimensions whatsoever. It is simply just a number. If you add a dimension of length to a dimension of length, you end up with a dimension of length. So L equals L plus L. So it checks. And we always go through every step when we are proving a dimensional analysis. Now, why do we say it might be correct, but not is correct? Dimensionally, this is correct, but I could make a small change to this equation and it would not be correct. It could be made in many places, but the easiest place to see is to replace the 1/2 term with another number, like 42. If this 1/2 was any number, as long as it did not have a dimension associated with it, I would still end up with L equals L plus L, and L would equal L. It would be dimensionally correct, but not a physics correct equation, because there isn't one that is v0 times t plus 42 at squared.